Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of one variable equations. This is standard 8.8c in the great state of Texas, and we are using item number 23 of the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a very simple equation here. 2x plus 3 equals x minus 4. We simply need to find the solution for x. I guess the only trick, if you want to call it a trick, is that there's no a, b, c, or d to choose from. We have to figure this out on our own and bubble it in. So let me rewrite this a little bit larger down here. 2x plus 3 equals x minus 4. All right, it's pretty basic. Can't ask for anything less complicated than this. We just have to apply what we've learned about isolating the variable and solving for x. So we need to keep a balanced equation, so whatever we do to one side of the equation we have to do to the other side in order to keep that balance. We're kind of viewing it like those balances we played with in science class when we were a lot younger. And whatever you put on one side, right, you'd have to put on the other side. That's what that equal sign does. That equal sign is that balance. So we can keep a balanced equation if we were to subtract x from both sides. So that's what I'm going to do first. Now, why am I subtracting x from both sides? Well, I want to get all the x's together, and I want to end up with a positive x. So if I do 2x minus x, that's just going to leave me with 1x, or I can just put x right there. I could, if I wanted to, take away 2x from both sides, but then that's going to leave me with a negative x on the other side, and negative x's are a pain because you're going to have to end up multiplying by a negative 1 at the end to get it to be a positive x. And so I'm going to subtract x from both sides simply because these are both positive x's, and subtraction is the inverse operation of addition, or having a positive number. So I've got x plus 3 left over equals, that's 0. We just kind of canceled that out there, minus 4. So let's clean that up. It's just x plus 3 equals that minus 4. We don't really need that 0. So now I need to get rid of my constants here. So I have a plus 3, so I'm going to keep a balanced equation. I'm going to subtract 3 from both sides. So those two cancel each other out. So it looks like I've just got x equals negative 4 minus 3 is going to make negative 7. So it looks like it's pretty straightforward. X equals negative 7. But since I don't know whether that's actually an answer choice or not, let's just take an extra step to make sure. Let's go back in here and plug these numbers in. I want to go ahead and do that just because, like I said, if I were to get negative 7 and that would have been one of the answer choices, A, B, C, or D, I would have felt good. Because if it wasn't there, then I knew I would have messed up somewhere. But there is no answer choices to verify with. So we're just going to do a little substitution. We're going to put in negative 7 wherever we see the x. And what we're trying to get is we're trying to get both sides to equal each other. If we get a balanced equation, that means that whatever we substituted in for that x is going to be good. So 2 times negative 7, well, 2 times 7 is 14, so negative 7 will make it negative 14. That's just negative 7 minus 4, that's going to be negative 11. So negative 14 plus 3, that's like 3 minus 14, and yeah, that's going to make a negative 11. All right, so that checks out, which means my negative 7 is good, so I do need to figure out how to bubble this in over here. So let's draw a little representation of what we're going to find on our answer document. You're going to get a little decimal right there. You're going to get 2 digits to the right of the decimal. We don't need either of those. 4 digits to the left. We just need one of those. And so we're just going to make our 7 right here. We need to bubble in our 7, but obviously, if that's all we do, it's going to be incorrect because it's negative 7. So over here on the left, next to that thousands place, you see a little positive and a little negative. And so what you need to do is you need to bubble in that negative right here to show that it's a negative 7. If you leave it blank, it's just going to default back to positive, and we don't need a positive 7. So there's our answer.